So in today's lecture, we are going to see the plotting of some functions. Let me write down that first. Plotting or graphing of some functions. The functions can be anything. We will see the basic plotting of some linear functions, quadratic functions, cubic functions, square root, etc. The purpose of why do you want to do the plotting is, the purpose of the plotting is that we are interested in studying the mechanics of particle in one dimension. And in that study of mechanics, we have to plot the distance as a function of time, velocity as a function of time, and acceleration as a function of time. So if we are going to represent the distance as s, then we say that distance as a function of time we have to plot. Velocity is v, as a function of time you have to plot, and acceleration as a function of time. Like this we have to plot or graph them in order to understand the mechanics. Graphs will help you to understand the physics better than if you have the numbers in the form of a table. You can also have numbers in the form of a table. It's called a tabular data. Understanding tabular data is not convenient, whereas if you plot them as a graph, same tabular data only, plot it as a graph, then you can understand the physics. So in any of these cases, whether it is s of t or v of t or a of t, it can be s, it can be v, or it can be a. It can be anything. So this is mathematically we say that these are functions f. And then there is an independent variable time. So this t is represented by x here. So therefore s of t, v of t, a of t, all of them you can represent it in general as an f of x. So in mathematically we say that any function can be represented like f of x, and this is a function of one variable. So this is called the independent variable. Independent variable. F is known as the dependent variable. The same is true here also. When we write s, v, a. So all of these things, so all these three things, whatever you have here, these are known as dependent variables. And the time is here, and this is the independent variable. So this is important. You need to know, you need to distinguish between the dependent variable and independent variable. Mathematically these are given these terminologies like this. Physically what it means is, independent variable means you can control. Dependent variable means you are not controlling but you are measuring. If you measure, it is dependent variable. If you control, it is independent variable. In mechanics we have equations like this. V equal to u plus at. And you have to plot the graph for this velocity. And similarly you have another equation, the s equal to ut plus half at square. And there is another equation which relates the v and u, v square minus u square equal to 2a into s. We will discuss about these equations, how to use them, all these things we will do later. But in today's lecture, our objective is how to plot the equations given in equations looking like this. That is an objective. So here the point to be here noted here is that these equations are of either it can be a straight line or parabola. When a 2 is involved, you see a power here. So when power is 2, then it is the appearance will be like a parabola. When the power is 1, so here you have a t to the power 1, that is u plus a into t to the power 1. When power is 1, this is going to be a straight line. And similarly, here also you have a square. So whenever there is a square, probably I will highlight here. So there is a square here. So there is a square here and there is a 1 here. So whenever this happens, then this is a linear. That is, linear means the graph will look like a straight line. And when the power is 2, this will look like a parabola. and once again there is a 2 here, so this will also be looking like a parabola. So the point to be noted here is that as far as we are going to discuss the mechanics of a particle, we will not be having any equation other than this. In particular, if you want to see this equation specifically, here is this. So 2a into s. So 2a into s. This equation can be written in an alternate way. For example, I can write v square equal to u square plus 2as. Therefore, v will be equal to square root of u square plus 2as. Now this u is the initial velocity. Suppose if the initial velocity is 0. That is the many cases that is the situation. Suppose if you are going to drop a ball. When I am dropping a ball from the terrace, then when I am dropping, the initial velocity is 0, therefore u is 0. When u is 0, this is actually 2 into a into s. So the velocity is square root of s. Now here, this we can write like this. So 2a into s, there is a to the power, there is a 1 by 2 here. So very similar to the case. So here you have seen 2 here, right? So there is a 2 here, and here you have the power 1 by 2. So that means you can get a power 1 that is there. You can have a power 2 or you can have a power 1 by 2. So this is power 1 by 2. So we have to draw graphs which are linear, which are looking like a parabola, and which are curves that are having power 1 by 2. So if you know this, then you can plot many different curves. We will see how to do that. So let us come down and see the otherwise we can erase this board. For the time being, I will move down and then we will plot. Now the starting point would be like this. So we will be starting with the equation that looks like y equal to mx plus c. This equation you have to compare with the equation for the velocity. V equal to u plus at. So these two equations you have to compare. If you compare them, let me put the x-axis and y-axis where it is. The x-axis is this. There is a x here, and the y-axis is y. When you write v equal to u plus at, what is your x-axis? T will be the x-axis. The y-axis will be v. So therefore the axes are to be identified before you can plot this. So therefore what you do is you rewrite this expression, you rewrite so that it looks like the first equation. So a into t I will write first. I will write the u later, which is similar to what I write here, y equal to mx plus c. So now you can compare that the x-axis is t and the y-axis is v. Now to plot this, you plot the x-axis and you keep the y-axis which is vertical. It is a tradition that the x-axis is represented as a horizontal line and the vertical axis is the y-axis. Generally, in general, this is the situation. You can interchange when some special situations arises, but in general, it is the rule that we will choose the horizontal line as the x-axis and the vertical axis as y-axis for many of the simple graphs. When you are going to three-dimensional graph, the axis names can change slightly. Okay, but for the time being, there is no problem. Horizontal line is x and the vertical line is y. Now, this x and y is corresponding to the equation number 1. So for equation number 1, you have x and y. But if you have an equation number 2 here corresponding to your mechanics problem, there the axis names are different. Therefore, you put a t here in place of x and here you put v. So everything is same, only the symbols are getting different. The plotting is like this. There is a c here. So there should be a point c which is on the y-axis. And then from there you plot a curve like a straight line like this. So this is how you plot for the equation number 1. So this particular equation that you have plotted is y equal to mx plus c. We will go through options for m. For the time being, I am assuming that the m is a positive number. So, and this particular height that you have drawn, so this height is c. If c is 0, what will happen? You can think you have to bring down this. This particular line down. Okay. So that means the y equal to mx plus c equation can be plotted as v equal to at plus u. Instead of u plus at, you write it as at plus u, so that things are clear. And here, when you are plotting in the similar manner, you will be drawing a line like this. And this particular point from here to the origin, that distance will be equal to u. So here you have a c, corresponding to that here you have a u. And we assume that the origin is the intersection of the x and y axis. X axis is this and y axis is this. Intersection is the origin. So that is this particular point. This point is the origin. So similarly, this particular point is the origin. This arrow represents the increasing direction. So you should not put arrow in both the direction. So that is, you please listen this carefully. When you draw an axis here, we put an arrow here and say that this is time. You should not put an arrow in the left side. Don't say this. If you say this is wrong. Okay. Both the sides you cannot put the arrow, and that is completely wrong. You have to put the arrow only in one direction. Okay. If both the side it is there, it is wrong. So don't make that mistake. Only in this means it is the increasing direction. What is the meaning of this? The meaning is this is the increasing direction of time. Similarly, there in this direction, if you draw a vertical direction, this means this is the increasing direction for the velocity. So there should be only one arrow should be there for the given axis. Okay. Now we have drawn the very simple situation where m equal to 0. So this point is important. So we have seen that this condition is important. For m greater than 0, this particular straight line is valid. So what will happen if the value of m changes? So that we will see by the next screen. We will go down here. So we can now plot like this in the similar manner. Now, so in the equation, m is known as slope of the straight line. You should remember one thing, that when we write y equal to mx plus c, this is actually known as the equation of the straight line. So therefore this word will always come. Straight line is there, and therefore this m will be the slope of the straight line. The c is known as intercept. This intercept will be on the y-axis. That point you have to remember. The intercept will be on the y-axis. Now there are three possibilities are there. This m have different possibilities are there. You can have m equal to 0. M is a number finally. It's just a number. It can be a fractional number or an integer, whatever it is. It can be 0. M can be a positive number. Okay. M can be negative number. All possibilities are there. So three options are there. So depending on the three options, your graph will change. So to draw that, let us draw it in this plotting. So you have the x-axis. Put the y-axis here, and we will draw for m equal to 0 case first. When m equal to 0 means slope is 0. When slope is 0, you should remember a point that our c is always there. So there is a c here. We are not talking anything about c right now. So there is a c. We don't touch the c now, and we are asking the question, what happens to m? So the first case we will discuss. So now we are discussing this particular case, m equal to 0. When m equal to 0, so this term goes to 0. When m equal to 0, what happens? You see, y equal to 0 into x plus c. Therefore, y equal to c. So this is the line. So y equal to c. So if you draw this line, then this is m equal to 0 corresponding to this. The second case, we will come to the m greater than 0. For m greater than 0, again you have to start from the C here and then you draw towards the up direction. So if you draw like this, then this is a straight line with m greater than 0. We say that everything is a straight line, only the slope changes. This is called 0 slope and this is called a positive slope. And finally we have to come back to the last option, which is the m less than 0. For m less than 0, again you start from the same point C and then rather than going up, you come down. So like this you come, like this you can come. And a straight line drawn like this is equation of the straight line whose slope is negative. Less than 0 means negative. So this is the idea. This is perfectly horizontal. M equal to 0 means perfectly horizontal line. M greater than 0 means it's moving towards the y axis. And if it is less than 0 means it is moving towards the negative side of the y axis. That is the meaning. Now what will happen? We ask a further question. What will happen if m is positive but if m is a larger value? For example, you can draw another straight line like this. I am drawing another straight line like this. Now what can you say about this line? Now this line, whatever I have drawn, is also m greater than 0. But what is the difference between these two lines? We say that both of them, that is the pink color one and the white color one, both of them are having positive slope. We say that the pink color one is having a smaller slope and the white color one has a larger slope. So the more vertical the line if you draw, then we say that we have a higher value for the slope. And once this is clear, we can, so the option for the m is over. Now we will come to the option for C. So now that the board is full, okay, we have to, probably I will erase the board. Okay, so what we have finished just now, we have finished the option for the m is completed. Now we have another constant, that is a C. So C can take again all three possibilities, namely C can be 0, C can be greater than 0, C can be less than 0. All the three possibilities are there, and now the drawing is quite simple because you already know where is the location of the C in the plot. So if you have the plot, for example, now if you draw the horizontal one as the x-axis, vertical one as the y-axis, and that is the origin O, then if C is 0, then the origin itself is the C equal to 0. C greater than 0 means, so this particular point, if I draw a point like this, this corresponds to C greater than 0. Now this particular point corresponds to C equal to 0. And C less than 0, you have to extend the y-axis toward the negative values. That means this is these are the positive numbers and here you have the negative numbers. So suppose if I put a point here, this particular point, then this particular point will correspond to C is less than 0. Now the equation of the straight line will be as usual. For example, if you had a straight line like this, suppose if this is the equation of straight line, then the same straight line will come here. You can see that the straight line will be the same. You are just shifting the straight line down here. So this is with the C greater than 0. So we can say that this is for C greater than 0 straight line. This is a straight line with the C equal to 0. and this is a straight line with c less than 0. So now you can play around with all possible positive values and negative values for m as well as for c. So c can take 0 positive negative, m can take 0 positive negative. So when you choose the all possibilities, you can have all possible plots of straight lines. So in particular, what is to be noted here is the following. Even though we have many possibilities, what is important point to remember is the following. So let us once again erase this. There is something which, if you remember, it will be quickly we can see what kind of straight line will come. If you plot, if you see any straight line that is going up in this direction, so this is going up direction, so this is going up, then we say that the slope is positive. So this point you simply remember, so that every time you don't have to check it out. When the plot is like this, which is coming down like this, so this is going downwards, then the slope means we represent say suppose if a straight line is there, we put a triangle, small triangle like this kind of a triangle represents slope. Okay, any line you draw, and for that line you put a small triangle like this. If you put this triangle, it means that slope. So that is the meaning. So we say that you put a triangle like this and say m greater than 0. M is slope, and therefore whenever the straight line is facing down like this, then you say that the slope is a negative. Now if you have a straight line, so if a straight line is facing up, then it is greater than 0. When the straight line is facing down, it's a negative slope. If it is neither up nor down, what is the meaning? Then it must be horizontal. Only horizontal thing. This is x-axis, y-axis you always write. Origin also you should always write. So O is the origin, x and y. So similarly, the third one you can quickly write based on this idea. If the straight line is not going up, if the straight line is not going down, then what is the option? The straight line should be horizontal. So that's an horizontal straight line. Now here, for a horizontal straight line, you cannot draw a triangle. When a particular straight line is going down like this or going up like this, you can draw a triangle. But for this horizontal straight line, you cannot draw the triangle. And therefore, you simply write that m equal to 0. That is the slope equal to 0. So regarding the straight line plots, we can make a simple conclusions like this. You have 4 ways of drawing a straight line. You can draw a perfectly horizontal line. You can draw a perfectly vertical line. You can draw a straight line that is facing upwards. You can draw a straight line that is facing downwards. Only 4 options are there. You don't have any other option. You can only change the slope of this straight line that is facing vertically up. For example, you can draw like this. This is also facing upward. You can also draw another straight line. This is also facing up. But in any cases, all of them will come into the same category, that the straight line is facing up. And here also you can draw many straight lines. For example, this straight line is also facing down. This straight line is also facing down. So you can draw a large number of straight lines, but in any case, this will come under only one type, that is facing down. So you have totally 4 options of drawing a straight line. In the first case, where the straight line is perfectly horizontal, you say that the slope is equal to 0. When the straight line is perfectly vertically up, it should be perfectly vertically up here, then the slope is equal to infinity. For this case, that is you can consider the set of all lines, not a single line. It's a set of all lines that you can choose, and you can say that it has a positive slope. You say that m is greater than 0, it's a positive slope. And in the last option where all the straight lines are facing down, their slopes are negative slopes. We say that m is less than 0. So m greater than 0, you have multiple straight lines. For m less than 0, you have multiple straight lines. M equal to 0 means exactly one straight line. You cannot draw any other line other than this. Similarly, m equal to infinity is exactly one straight line. You can draw parallel lines. That is a different story. You can draw a parallel line like this. So this is all these lines will have m equal to 0. They are all parallel lines. So you cannot distinguish one line from other. But in the case of m greater than 0, for example, you can distinguish one line from other. Okay, the line number 1 is different from line number 2. But here, line number 1 and line number 2 are parallel to each other. So they will describe a similar physical phenomena. So that is the point. Similarly, in the case of m equal to infinity, you can draw a parallel vertical line. So whether it is this line or this line, it doesn't matter. So line number 1, 2, 3, all of them will have m equal to infinity. So these are the only ways in which you can draw straight lines. Purely 0 horizontal, infinite perfectly vertically up, and positive slope. So from the appearance itself, you can decide what kind of slope is there. So that's the conclusion. The next point, after drawing the straight line, what else we have to do? So there is another point that you have to do here. Let us ask the question, or we will see what is the situation when you draw a straight line like this. Let me draw a set of 3 straight lines. The first straight line is like this, which is perfectly horizontal. The second straight line, I will draw a straight line which is having some positive slope, that is like this. And the third straight line I will draw which is perfectly vertically up. It's like this. I have 3 straight lines. You can clearly say that the slope equal to 0 here for the first part, that is from here to here, the slope is 0. And from here to the second portion, the slope can be a positive number. Okay, for the time being, you need not put any, you can assign any number you like. For example, let me assign a value equal to 4. So slope equal to 4. It can be any number, 4, 5, 10, 20, doesn't matter. It's a kind of a slope that is having a number 4 here. And here perfectly infinity. So this is the situation. Now what is the question or the point to be noted here is that from here to here, let me show here. So from this point to this point, all these points, the slope is a constant. It doesn't change anywhere along this line. Slope is a constant. Now similarly, when you are coming to the next part of the straight line, from this particular point to this particular point, again the slope remains constant, but now it is 4, not 0. Similarly, in the case of the last option, which is the vertical straight line, the slope is always constant, which is equal to infinity. So the point is that we have constant slope. This is a constant here. This number is a constant. Now the question comes, what will happen here? So here there is an abrupt sudden changes there. Sudden change in slope from 0 to 4. That is at this point. Similarly, at this point, what happens? You can easily say that there is a sudden change in slope from 4 to infinity. These kinds of sudden changes, mathematically you can draw anything, but physically, any physical process or a chemical process, a biological process, anything naturally occurring events generally doesn't allow for sudden changes. Suddenly something doesn't change. For example, temperature, when you are boiling the water, for example, the temperature slowly rises. It doesn't suddenly jump from room temperature to 100 degrees centigrade. Whatever heat you supply, the temperature increases slowly. Sudden changes are not there. So the point to be noted here is this particular word. This sudden is a term that is not suitable for describing physical phenomena, excepting for some special or some special phenomena like phase transition, critical phenomena, etc. Excepting for those events, most of the physical processes are not sudden, they are always smooth. So physical processes are smooth processes. You take any physical process in general, no, I'm not talking about all processes, majority of the physically or naturally occurring processes are smooth changes. Therefore, now the question is this: we have straight lines and we have a physical process. I want to represent a physical process by some curve. So therefore, when you are plotting with a straight line, there is a difficulty. The difficulty is straight line. When you join multiple straight lines, the point of that is the junction where there is a change in slope is sudden. Therefore, this region cannot represent a physical phenomena generally. Such kind of sudden changes generally don't occur, and therefore what happens is straight lines are not suitable for explaining this. So what you do is, rather than drawing three straight lines, you slowly change its slope. So it will be changing like this, and then it goes to infinity. So now what happened, we have to compare the previous diagram. Well, the previous diagram is here. You see in the previous diagram, it starts from here, always it is constant value, suddenly changes to 4, and then suddenly changes to infinity. Instead of this, now we have drawn another curve here. So in this particular case, the whole region, you can say that you have a slope here, you have a slope here. You can represent each point here. Now if you see, each place you have the slope changes from point to point in a smooth manner. So that is the slope at this particular arrow. Slope at the point 1 is different from the slope at the point 2, which is again different from the slope at the point 3, which is again different from the slope at the point 4, and so on. That is what we mean to say from point to point. Point to point means as you change the point in the curve, the value of the slope changes smoothly. That means you can have a 0 slope as the first point, not the first point, let us say 0. So at the point 0, so this is the point number 0, my slope will be equal to 0. At the point 1, my slope will be equal to, slowly it will increase, say 0.3. At the point number 2, it will increase to 0.7. At point number 3, it will increase to 1.2. At point number 4, it increases to 1.9. So like this, the number increases. So it doesn't make a sudden change in the case of earlier case. In the earlier case, you have seen that 0 changes to 4 suddenly. So instead of that, now in this case, it changes smoothly. So therefore, this kind of curves, so in general, we will make a conclusion, this is a curve. So this kind of a curve can represent most of the physical phenomena. Any physical phenomena you take, you can represent it by a curve. Now we want to know what would be the equation of a curve. So certainly this curve is not a straight line. This is not a straight line. So therefore, now you understand why we have to study about curves, because physical processes generally are represented by curves. Whether you study mechanics or it's a thermodynamics or electromagnetism, optics, whatever be the thing that you study, in most of the situations, in many cases, curves are required. In some special cases, straight lines are required. So we need to have some idea about how to draw a curve and how the equation will look like. That is exactly what we are going to do now. So we are going to see how to plot some simple curves which are related to study the mechanics of a particle in one dimensions. So we are planning to draw curves that are looking like f of x is like x square, or the function f of x is like x to the power 2, x to the power 3, etc. In general, you can have any plot x to the power n. You can also plot x to the power 1 by 2, x to the power of 1 by 3, or In general, the function could look like x to the power of 1 by n. These are the most frequently used one. The first two is very much useful. X to the power 2 and x to the power of 1 by 2 is frequently used. Plotting for x to the power 3 and x to the power 1 by 3, you have to make a small correction or a small adjustment. And similarly, if you make further small changes, you will be getting different plot where n can be any number. You can substitute a number which is greater than 1. So we will see this. These two things are different from what you have done for a straight line. For a straight line, f of x goes like x. This is a straight line. In fact, the power, if you see carefully, it's a 1 here. In fact, traditionally you write y equal to mx plus c. That is the equation of the straight line. If you assume that this particular c is 0, okay, c can be 0. It's only an intercept on the y-axis. If the straight line is passing through the origin, c is equal to 0. And m is actually the slope of the curve. And you can assume that, for an example, you can assume that we have a slope which is equal to 1. Then what is left out? That tells you that y equal to x. And this y can also be represented as f of x. Both are same. Either you say y or you say f of x. Both are same. That's what I have written here. And then there is a power is this 1 is there. That is the meaning that you have. The x to the power is 1 that you have. And that is exactly which I have written here. So if f of x is like x to the power 1, that will represent a straight line. And when f of x is, in general, it can be anything. So all these things, how can you represent? Here you can represent f of x is like x to the power some power a, where a is not equal to 1. So instead of writing x square, x cube, x to the power n, x to the power 1 by 2, 1 by 3, all these things no need to write. You can simply write one condition that f of x is like, what is the meaning of this is, you can say that you can read like this, like f of x is like x to the power a, or you can say goes like, whatever thing you can say. So f of x goes like x to the power of a. That is the behavior. The meaning of this particular symbol tilde is behavior. F of x behaves like x power a. In this particular case, you say that, in this particular case, we say that f of x is behaving like x to the power 1. And here we say that f of x is behaving like x to the power of a. So that is what we mean to say. And whenever you have a situation where f of x goes like x to the power a, where a is not equal to 1, then that is known as a curve. That is, it is not a straight line. By curve, what we mean to say is that straight line behavior is deviated. You are deviating from the straight line. That is exactly what we mean by saying a curve. Straight line is a special case of a curve. By the way, we are not rejecting the case that straight line is not a curve. Straight line is also a curve, but it is a special curve whose slope is constant. Whereas in general, for a curve, the slope will vary. Okay, so that is the point. So let us now finally come to the plotting case. We are not discussing exactly how to plot an equation. Suppose you should remember one point. You know already that y equal to mx plus c is the equation for a straight line. Suppose I give you y is equal to 16.23x minus 19.23. You draw the straight line for this. We are not going to do the plotting of this particular line. Okay. For this you have to do little more work. More exercise is required how to plot exactly a straight line that looks like this. We are not doing that. What exactly we are doing is, we have some slope which is greater than 0 and we have an intercept c which is less than 0. If it is the case, how the particular curve will look like. So the appearance looking like, that is very important. Not exact straight line. Exact straight line means you have to exactly draw 16.23 and minus 19.23. We are not going to do that. What we are going to do is the appearance of the straight line that looks like this. So in this case, what happens? Minus 19.23 is a negative number. So put a negative number, you put one dot here. That is a C. And this particular greater than 0 tells you that the straight line should be facing up. Therefore, it should face up like this. That's all. So if you calculate the slope of this is supposed to be 16.23, and this particular number here should be a minus 19.23, and there is a 0 here. This is important. 0 should be here. So this is 0, this is minus 19.23, etc. and plus etc. So the appearance of this particular equation will be like this. That's what all exactly we say. We are not specifying exactly what are the values along the x-axis, etc. That if you want to do, you need a proper graph sheet and then you can plot it. But that's not required for the time being. What all we are saying is that we are trying to plot the almost the characteristic features we will be getting. That is a point to be noted here. So we will come back to the curve once again. I have just illustrated for the case of a straight line that we are not drawing exact lines, but we are drawing lines that how the lines will behave like when the slope and the intercept is changing. So let me erase this board. So coming back to the straight line case, so what did we discuss 1 minute back? So we have seen that we want to plot curves that are looking at x to the power a. So we will see that. So we want to plot any graph that looks like x to the power a, where a is greater than 1. In fact, you can ask why a is greater than 1. A is not equal to 1 is the condition for curve. You have seen here. You see this? A is not equal to 1. So if A is not equal to 1, you get the question what it is. It can be greater than 1, it can be less than 1. So you have two options are there. So therefore, A is not equal to 1 is the condition for a curve. So we have two options. A can be this or A can be less than 1. So right now in this first case, we will discuss the situation where A is greater than 1. It means that what is the meaning of this is like this. You can plot y equal to x to the power of 1.3, y equal to x to the power of 3.9, y equal to x to the power of 7, y equal to x square. Anything can be plotted. That's the meaning of this. The meaning of this. Suppose if you are going to talk about the case where a less than 1, x to the power a, that means I am going to plot anything. Okay, I am going to plot anything that can be looking like y equal to x to the power of 0.32, y equal to x to the power of 0.5, y equal to x to the power, y equal to x to the power 0.79, y equal to x to the power of 0.91. So these are the cases. Anything you can plot. These are the a less than 1. This is a greater than 1. So how these curves will look like. That is what exactly we are trying to explain. This is very easy. You will see how to do that. The situation is quite simple. What all you have to do is you simply draw one straight line. Say, I will not put, if you want to draw the axis, let me draw. So that's a y-axis here. This is an x-axis. So you put the horizontal axis as x, vertical one as y. Always put the origin as 0 and then draw one straight line. It could be any straight line. Typically I will draw y equal to x curve. So this is the y equal to x straight line. Now what you do is, from this straight line behavior, you deviate. So suppose deviating means I will not follow the straight line, but I will slowly deviate from the straight line. See, I am now deviating like this. I can deviate like this, or there is another option to deviate, that I can also deviate like this. These are the two ways in which you can deviate a straight line. I don't want to follow a straight line means either you can go to the left side of the straight line or I can go to the right side of the straight line. If you go to the left side of the straight line, the equation of this particular line is y behaves like x to the power a large number. It can be x square. For a simple situation, let me tell you, it looks like y equal to x square. Whereas if you are going to deviate from the straight line behavior, and that is you are moving towards the right side of the straight line, then the equation will be looking like, or you say that the behavior is like x to the power of 1 by 2. there is no need to put a 2 here. If you want, you can put 3 also. If you want to put a 3 here, you put x to the power of 1 by 3. It's only the deviation to how much extent you deviate to the left side. By the same extent you have to deviate to the right side. Then the behavior is like this. So which means that you can now plot different curves of different steeps. Now you can imagine how to plot x to the power of 3. So can we plot an x to the power 3 here? This is x to the power 2. X to the power 3 means it has to be much more steeper. So deviate more and more. So I am deviating more and then going like this. So in this case you can say that okay, so the deviation is slightly. So it is slightly away from x equal to 2. Then we say that x to the power of 3. So that is the meaning of drawing x to the power of 3. So in general, the meaning is clear that you can draw curves like this. And specifically, we are not interested in all numbers 2, 3, 7, etc. Everything is not required. What you want to plot is y equal to x square you want to plot, and y equal to root x I want to plot. This root x is actually what I say x to the power 1 by 2, or it is 0.5. Okay. So the curve, how do you plot this particular graph is like this. So you can quickly plot like this. You say like this is so this particular graph will be, we say that this particular line, this particular curve is y equal to x square. Now there is an interesting point to remember. Suppose if you put a mirror, so this is a mirror for example, what will happen? If this is a mirror, then what will happen is, the straight line that you have drawn, not the straight line, the y equal to x square curve that you have drawn will be reflected. So that will be seen in the mirror. So you have to complete this in this particular way. And the whole thing is the y equal to x square. So this is also y equal to x square. So y equal to x square has two parts. The first part is corresponding to the x-axis. There is a 0 here. So all these values are plus values. These are positive values for x. These are negative values for x. So therefore y equal to x square looks like, so generally we say that it looks like a parabola. Okay, this the whole thing I am drawing here. So we say that this is looking like a parabola. So our conclusion is like this. Whenever a function, the function is actually y. Whenever a function is looking like a quadratic function. Quadratic means a times x square plus b times x plus c. Whenever a function looks like a times x square plus b times x plus c, then the appearance is that of a parabola. You can have special situations where b equal to 0, c equal to 0. When b and c's are 0, these terms will disappear, and when a equal to 1, you get this y equal to x square. So it's a special case. So you should always remember that it's a quadratic function. So we say that this is a quadratic behavior. This behavior is what we put this symbol. Okay, we say that y behaves quadratically. That is what we mean to say. Now the other case is what this, you have a square root of x. Square root of x is exactly, you are inverting them. Okay, if you take a square root on both the sides, what you get a root of y equal to x, and that's what we are trying to put here. The root x behavior is another special case which is required frequently. It's required, and therefore you should know how this particular equation will look like. So again we will plot the curve. First you start the y-axis, then you have the x-axis, you have the origin which is the intersection of x and y. Well, these are some positive numbers, this is also positive numbers, this side you have negative numbers, and this side you have negative numbers. Now we are going to plot y behaves like square root of x, which is nothing but x to the power of 0.5. You should remember that 0.5 is less than 1. And also you should remember 0.5 is not equal to 1. Now why do you want to know all this not equal to 1, less than 1 is? Sometime back I explained you. Let me see whether that particular screen is there. Do you have that? Well, the point I explained you. Yeah, this is the place. Can you see this? The condition is that number should not be 1, number should be less than 1. Okay. So if these two conditions are satisfied, how the graph will look like? Answer is here. This is the answer. How the curve will look like is, it will look like a situation where you deviate from the straight line, and you have to deviate this straight line in such a way that you deviate to the right side of the straight line. So this is the straight line. This particular thing is a straight line. You deviate away from the straight line in the towards your right hand side. Okay, if you deviate to the left hand side, you will be having x to the power of 2. That's exactly what to remember, and we are going to plot that now. Okay, so let us see. We'll go back to that screen where we are planning to plot this. Yes. So this is the curve. So when y equal to square root of x, how the graph will look like? It will be looking like this. You start from here, you keep moving like this, and then it goes like that. So this is the appearance of the graph, which is y equal to square root of x. Now the interesting point is that you should put the mirror here on the x-axis. Suppose if there is a mirror, so assume that x-axis itself is a mirror, then what will you see in the mirror? That particular curve will be reflected in the mirror, right? Therefore you can plot like this. Same thing, whatever is there on the top, that will be reflected down like this. You can plot like this. So this is also same curve. This is also square root of x. Only thing is, this is on the negative side of y, and that is the positive side of y. But in all the cases, the value of x is positive. You should remember that in all cases, x is greater than 0. Whether it is blue color curve or the white color curve. So finally, we will represent like this. The graph will be looking like this. This is also a parabola. So the point to be noted here is that parabola, you have two types. Now let us make the conclusion. Our conclusion is like this. You can have a parabola like this, or you can have a parabola like this. If the parabola is like this, then y is behaving like x square. If the parabola is like this, then we say that y is like square root of x. So this is what is important that you have to remember. You can write alternate way you can write, but that is not important for us. Suppose if you square this equation, what will happen? You square both the sides. Then what will happen? Y square will behave like square root of x whole square. Simplify this. Y square will behave like x. Isn't it? So this is like behavior. So it doesn't matter whether any constant is there or not. So you can multiply any constant you like. Now you should remember that there is a 1 here. X into 1. So you can ask the question, why only 1 should be there? You can have 10 or you can have 75. Any number can be there. So you can have any number you like. Traditionally, we write a number 4 times a, where a is a constant. Then what happens is this equation is looking like y square equal to 4ax. And this is what, this is square is not there. Y equal to 4ax, and this is what we say parabola. So the way of writing this is only optional. The point to be noted is that y behaves like square root of x is very important. You can rewrite and multiply by, it doesn't matter whether you multiply by 4a or 25b, it doesn't matter. So ultimately you should have the relation like y behaves like square root of x. Similarly, here you will be having y equal to y behaves like x square. So this is our conclusion. Our conclusion is the typically square behavior is very important. Cube and higher powers, what will happen is that the steepness will increase. So it's not important for the time being, it's not important, but I will just give a information to you. What will happen if it is a cube? So let me draw it here. So already you have the graph for the square, right? You have the graph for the square. What will happen if it is a cube? Suppose y equal to x cube, what will happen? So small change is there. What all you have to do is you make it little bit steeper, that's all. So you make steeper and it goes like this. So that's the curve. So you have to make a little adjustment for the y equal to x square curve. You make it more and more vertical, steep. Then it becomes x to the power 3. You make it much more vertical. Then you can plot. If it is x to the power 7, what will happen? What will happen means you try to make like this. This goes very steep like this. So then it becomes x to the power 7. That's an idea. So these things are not very important for the time being. This is the only thing you have to remember. The behavior of y, which goes like x to the power 2. Coming back to the square root case, let us see the square root case. You can ask the question that suppose I have another option where y goes like x to the power 1 by 3. Now this is actually x to the power 1 by 2. So 1 by 2 is becoming 1 by 3. Then what will happen? Then what will happen is exactly you have to draw like this, a little bit. It comes like this. And then it saturates here. So this kind of a curve will be x to the power of 1 by 3. If you have x to the power of 1 by 10, if it is x to the power of 1 by 10, then it will go like this. So that kind of a curve will be y goes like x to the power of 1 by 10. So what will happen when 2 becomes 3, 3 becomes 10, the curve will shift like this. So this is what you have to remember, and the same thing has to be reflected down. They should be reflected down here. So that's all. That is a point that you have to remember. And we have plotted two important cases. One is the x square case. The other is the root x case. If any other thing is required, at that time I will explain you specific cases. For the time being, what all you know, right now what all you know is, you know how to plot y equal to mx plus c. You know how to plot y equal to some alpha times x square, and you also know how to plot some beta times the square root of x. Okay, this alpha and beta are simply multiplication factors. Scaling means you have to draw a small parabola or big parabola. That is this alpha. So see, I can draw a parabola like this, or I can draw a parabola like this. So here I can say alpha equal to 1, and here alpha is 5. So I am drawing 5 times large parabola. That's all. That is the meaning of that. Suppose if you have alpha is equal to 1 by 3, I will be drawing a small parabola. Okay, this is alpha equal to 1 by 3. So the alpha is actually a scaling parameter. Similarly, beta is a scaling parameter. If beta equal to 1, I have this kind of a graph. If beta equal to 5, then I have to draw a 5 times bigger size one. So we say that this is beta equal to 5, this is beta equal to 1. And if you want to draw a small parabola like this, we can say this is beta equal to 1 by 3. So therefore alpha and betas are known as the scaling parameter. And in this case, you already know that slope, intercept, and this is the y-axis. And you should always remember that this x, everywhere x is there, independent variable, and y is the dependent variable. Okay, I hope that this amount of information is right now sufficient. We will now jump into solving the problems which are asked in the entrance examination. Specifically, we will solve the questions that are asked in the entrance examination, so that you can see how easy the questions are. Okay, they are not difficult at all. We will see it now. So here we have one question from the AIIMS entrance exam. Probably this is sometime in 2003. The question is this: a ball is thrown vertically upwards. Which of the following plots will represent the speed time graph of the ball during its flight if the air resistance is not ignored? So you can see the question. Now the points you have to remember. The first point you have to remember from this question is that the air resistance is not neglected. This is important because the usual one-dimensional motion, the equations that you see, all these equations are based on the assumption that all sorts of resistances are ignored. So that's why the question says that don't ignore that if it is the case. This is the first point you have to remember. The second point from the question is that we have to plot the speed versus time graph. That means you need to plot what is known as S of t. It depends on what kind of symbol. So let us I'll write as such now. It is a speed time. So usually speed, if you are going to represent as velocity, and time is an independent variable, so you should write like this. So it is actually a v of t. The meaning is that the v of t plot. Well, and the second point is noted here. The third point to be noted from this description is that during its flight means the entire duration. Okay, so you have to understand this. It is not part of the flight. During its flight means so entire time duration. So what is meant by entire time duration is you start with a floor here or ground. This is ground level. You throw a ball up. So you have a ball here and you throw it up. Then what will happen? It will go up all the way and then reach maximum possible height here. After reaching the maximum possible height, it will come back. So first it will go up and then it will return back and then it will come and hit the ground once again. And that is what we say it's one flight. One flight time means it starts there, goes to the maximum possible distance, stops there momentarily, that is for a one instant of time, and then return back and hits the ground. After hitting the ground, it will again jump. That's a different story. But here, its a flight time means starting from t equal to 0. So at time t equal to 0, you are initiating the process, and at a time t is equal to t1, it will reach the maximum height and it will return back with another time t is equal to t2. So at time t is equal to t2, it will return back to the original place, which is the ground level. Now during this entire process, so that means the plot will be looking like this. We do not know how the plot is going to look like, so at least I will draw the axis here. So time is an independent variable. So the independent variable should be plotted along the x-axis. We should not write x. So you should remember that don't put x here. So usually what happens is you have a temptation to put x here. So let me once again write down t is equal to t2, it is coming back. Usually what we do, usually put x. Don't put x here. Specifically you have to find out what is the independent variable. So this is wrong. Don't put x, and you always put what is given in the question. So here it is given that the speed time graph. So time is the independent variable. Independent variable should come in the x-axis and the speed is along the y-axis. So usually speed is represented by v is the velocity. So we are asking the question, what would be the v versus t graph? That's an origin, and the time is t equal to 0, it starts. So this point is t equal to 0 and this could be t1. So t1 is the place where maximum height is reached, and t2 is the time where it has come back to its original place. And here a ball is thrown vertically upward. That is what is given, which means that you should provide, there is one more information which is not given explicitly in the problem, but you have to understand. A ball is thrown vertically upward means when you are throwing, you have to provide initial velocity. If you don't give any initial velocity, then the ball will not go up. It will stay only in the ground level. So therefore, indirectly the meaning is that there is an initial velocity given. So that particular concept or that particular point should be clear to you, that an initial velocity has been provided. The value of the initial velocity is not given, therefore you keep it as u. So we don't since it is not given, let it be the value of u. Only point is, the point to be noted here is that the initial velocity is not equal to 0. That is the point to be noted. If it is equal to 0, there is nothing to do, because the ball will not go up. So there is no graph will be there for that. Okay, coming back to the question once again, a ball is thrown vertically upwards. Then how the graph is going to look like? Actually, this is only part of the question. In the actual question paper, four graphs are given. I mean, first graph here, second graph, third graph, and fourth graph. So four graphs are given here. Some graph will be given here, and you have to identify which graph will be the correct graph. That is the question actually. We will see what type of graph will actually come. After that, we will look into the four options. So directly by looking into the option, we don't want to identify directly like that. So that is not the procedure in problems in physics. Usually you have to understand the problem and then try to find out what is the answer. So here is we have already identified the plot here. It should be V versus T graph. Now in order to draw the graph, actually you have to use some of the equations that you have. The first equation is that you can use V equal to U plus AT. This equation you can use. You can use the distance equation, S equal to UT plus half AT square, or you can use the another equation, V square minus U square equal to 2A into distance traveled. Now the point to be noted is this: if you use this equation, we can plot V as a function of T, because V is here, T is here. If you use this equation, you can plot S as a function of T, because S is the variable, T is here. So here is there, here is there. And remember, S is not the speed, S is the distance traveled. So this is the velocity, which is the speed. And if you are going to use this equation, I can plot V as a function of S, because V is here and S is here. So now you have to choose which equation is most suitable for a given problem. For our given problem, clearly tells you that calculate the speed time graph. So it is given in the question paper that the speed time graph. So it is there here. You see this. So this is the speed versus time graph. So based on that information, once again we will come back here and see which equation is suitable. So this is the correct equation that we have to choose, and these two right now you don't have to use. So therefore we will have V equal to U plus AT is the equation that we have to use. So when you do this, V equal to AT I will write first and I will write U later, and that equation is Y equal to mx plus c. So automatically, immediately you can write down that this being the equation of the straight line, you can immediately think what could be the plot for the first part of the journey. Well, so now that we have decided that we have to use this particular equation, so the equation that we are going to use, that we have decided that this is the equation. That's the first equation that we are going to use. So if it is the case, we will finally write down here that the final velocity equal to acceleration times the time plus the initial velocity. So that is the expression for the velocity, and this has to be written specifically for a given problem. Acceleration in this particular case, it is vertically thrown upward, and therefore the gravity is acting. Now the doubt will come whether the gravitational value, that is the g, acceleration due to gravity, shall we put a plus g or to put a minus g here? So that is a question. Now that can be decided easily from the equation. Now suppose you think about like this. There is a v equal to ut, v is equal to at plus u. Now that is equal to gt plus u. You have one option. So either you can write like this, that is a plus gt plus u, or otherwise you can write v is equal to minus gt plus u. There are two ways you can write, because it is vertically thrown upward. Sometimes it is plus g and sometimes it is minus g, and you may get a confusion when to put a plus g and when to put a minus g. So to avoid all the confusion, you now follow what I am telling. So what you have to do is, you keep increasing the time because your stop clock will always move. Stop clock will not work, will not stop any time. Therefore, T will increase. T will increase always. So when T increases, G into T is a negative number. So there is a increasing negative value. So there is an increasing negative value, and this is a constant positive value. This is a constant positive value. The constant positive value can be 100. Increasing negative value means minus 1, minus 2, minus 3, like that it will increase. Initially it starts from 0, and from 0 onward, 0 will go to minus 1, minus 1 will go to minus 2, like that it will keep on increasing in the negative direction. So if this is plus 100, then if you wait for sufficiently long time, you get an opportunity that this number will become minus 100. There is a possibility is there, because this is continuously it will vary. So whatever be the number, when certain time comes, it will cancel exactly this number, and in which case this V will become 0. This is possible in this particular case. Now you take this particular case, V equal to plus GT plus U. Suppose you want to think that this is a correct equation, then the same idea you follow. If you follow this, what will happen? If U is 100 here, and G is a positive number, and T is an increasing number, T is also positive. So this is a positive number. So this is positive number, and this U is also positive number. Two positive numbers I am adding here, and therefore this V will always increase. It will never become 0. Is that point is clear? Therefore this situation is quite different from, so you have to understand one thing, that this particular situation is different from what you write like this. So two situations are different. Now you have to come back to your experiment and think which one is most suitable. Here, just now I have seen that you have a ground level. From the ground level, you throw the ball and it will go up. And it will keep on going in the up direction until it reaches some height where it will stop momentarily, and then it will return back. What is the meaning? The meaning is at time t equal to t1, it has reached maximum height, and when it has reached maximum height, it will not move any further. That means temporarily means at a particular instant of time, it will stop and then return back. Therefore, v equal to 0 happens at some time. This is what you should remember from the experiment. And coming back to this equation, this gives the possibility for 0. There is a 0 is coming because 100 and minus 100 may get cancelled. But here always two positive number will be there, and the velocity will keep on increasing and it will never come to 0. So our conclusion therefore is choosing a plus g is not correct, whereas choosing the minus g is correct for the upward direction. Like that you can make a conclusion. So if it is the case, you can write down that a is equal to minus g multiplied by time plus the initial velocity. So this is how you write the equation, and this equation is valid for the upward motion, because our the equation is valid for the upward motion. So downward motion we will do once again. That means we are asking the question within this region, that is 0 to t1, how the graph will look like. There is another region t1 to t2 that we will see later. So right now we are asking the question how to draw a graph between 0 and t1. So okay, coming down here, once you have written this equation, so now that we have written this equation, now things will be quite easy to do. So let us say we will put a box for this. So this is your final equation for plotting. You can quickly plot this because you already know how to plot straight lines. You have the time along the x-axis, the velocity along the y-axis, origin is there here, and it tells you that there is a minus g. Minus g means what? The slope is negative, and a negative slope means a straight line that has to be facing downward. So this is correct. Facing upward means we cannot have a minus value. Therefore, you should draw a straight line that is facing downward. So straight line should start from here and then come in the downward direction you have to come. Okay, you cannot draw horizontal line because g is not 0, because this g is the slope. This g is, you know that it is the value is 10, so this is not 0. If the acceleration due to gravity is 0, I can draw a horizontal line. If the acceleration due to gravity is infinity, I can draw a vertical line, perfectly vertical line. But you know that g is equal to 10. Since g is equal to 10, which is a positive number, and you have a minus value here, therefore this is the correct option. That means you have to draw a straight line that is facing down. That part is clear. Now the question is whether you want to draw the line. Where do you want to draw? You can draw a line here. For example, I can draw a line here, or I can draw a line here, or I can also draw a line here. Everything is a line which is facing downward. How do I draw a suitable line for this? Now that depends on the initial value u. So you have to choose some positive u value. So let us choose that. I'll remove these lines that I have drawn. So I have to choose the value u here for the initial time. So that means this is the what you call the intercept. So let me put the intercept here. So this is the intercept, and that value is u. In fact, what is the meaning of u is this height, this particular, this is the u. And then you have to choose this particular straight line coming down like this. So it will be coming down like this. When it comes here, this particular time is t1. What is t1? We have written here. Sometime back we have written that the particle is thrown vertically up and it is traveling like that. It reaches the maximum height, and at that time your stop clock is showing t1. After that it will come down and it will hit the ground. When it hits the ground, your stop clock will show the time t2. So this is the t1 and t2. And therefore we have written a t1 here. So 0 is the time at which you start the experiment. t1 is the time at which it has reached the maximum point. This is the graph. That means you have finished 50% of the problem. So you have drawn the graph for half of the journey. So, okay, it's not the entire flight. Flight means the complete duration of the experiment. Okay, now right now 50% is over. That means now the ball has reached the top of the maximum height it has reached. How do you find the maximum height? That you should know here. Now since the final velocity should be equal to 0, in fact you should also know how to calculate this. We are going to use this equation. Which equation we are going to use? We are going to use v equal to u plus gt, that is equal to minus gt plus u is there, v equal to this. Now when time is t1, I will write t1. When time t is t1, my final velocity is going to be v, and at which case what will be v? That will become 0. This is the final velocity. When time is t1, when my stop clock is showing t1, the ball is temporarily stopped and it is going to return back. Therefore v equal to 0. And if you simplify this, that is minus gt1 plus u equal to 0, we can get that t1 equal to u divided by g. So therefore this value which is given here, from here to this particular point t1, this distance is equal to u divided by g. That completes the 50% of the problem. Now the remaining 50% of the problem is now returning back. That means the ball is now at the maximum height. This is at the maximum height and it is returning back in the same vertical path it is returning, and then it is coming to the ground. So therefore what would happen? There is no need to do any more calculation. In fact, it is going to get the retracing the path. Only thing is the g will become plus. Then it exactly opposite thing is going to happen. So therefore only thing is that g will become a plus g when it is moving downward direction. And therefore you plot how I am plotting this line. Let me tell you. This is a straight line with a negative slope. This is a straight line with a positive slope. That's all. So if I draw one here, you can draw another anywhere, but your experiment started at the same time. Therefore these two things are joined. Okay, otherwise you can draw one line here, another line here, but there is a gap here. No? You don't have any gap like this. When you are performing the experiment, the ball goes to the top and then immediately it returns back. So everything happens at the same time. So this particular time, the same time only, you have to draw this particular straight line in such a way that the slope equal to g, this slope equal to g, and that slope will be equal to negative g, because you already know that this is negative slope and that is a positive slope, and it will reach with the same velocity. So it will reach to this particular point, and that would be equal to t2, and you can find out that t2 is equal to 2 times u divided by g. So this is the actual, finally this is how the graph is going to look like. Our final graph will look like this, but there is a point to be noted. Actually that is the question. The question tells you that this graph, let us say, let me make the conclusion. This is the answer. So this is the answer if air resistance is neglected. So this is the point to be noted. All these equations that you write, where are the equations that you have written? These 3 equations: V equal to U plus AT, S equal to U plus half AT square, V square minus U square equal to 2AS. All these equations, including F equal to MA. Well, F equal to MA, when you write that particular equation also, when you write like that, in the absence of the forces, okay, the problem is solved in the absence of the external forces. Okay, so that is the point you have to remember. All these equations are valid when the resistances are ignored. Not necessarily air resistance, any other resistance. Friction, for example, friction is also ignored. When you are solving some problems in inclined plane, you neglect the friction. Okay. So if you are including the friction, then the problem is a different problem. At that time you cannot use this equation. This equation V equal to U plus AT cannot be used when you are using friction. So that is a point to be noted. And therefore, provided that the air resistance and all other type of frictions are neglected, this graph is correct. But your question paper clearly tells you that if the air resistance is not neglected, so that is also given here. So here it is. The resistance is not ignored. So that is a question. So the answer is fairly simple. We will see what is the conclusion. Now what the resistance will do, that's what you should know. There's a small point you have to remember. The air resistance will change the velocity. What is the purpose of air resistance, or what exactly this resistance is going to do to the ball is that the air resistance will change the velocity of the ball. In this experiment, whatever the ball or object, whatever object you are throwing, that particular object, it will change the velocity of the object. How it will change? It is like this. So as to, in what way it will change is very important. So as to deviate from linearity. That's all. This is the only information you need to know to answer the question. So let me tell you once again. If the air resistance is neglected, means you don't have to worry about the deviation from linearity. You maintain your linearity. Linearity means a straight line behavior. Whatever line that you have drawn, here you have a line. Okay, that line is a straight line behavior. So it's a perfect straight line. So you are drawing a perfect straight line. This is called a linear behavior or linearity. That's exactly what we mean to say. So deviation from linearity is neglected. Here you see there is neglected. What is neglected actually? Deviation from linearity is neglected. That means perfect linearity is maintained. So what now you can immediately tell the answer. If the air resistance is not neglected, means what you have to do? You have to consider the deviation from linearity. That's all. If you consider the deviation from linearity, then what exactly you have to do is you have to slightly You have to slightly change the graph so that it is not a straight line. That's the meaning. Deviation from linearity means changing a straight line to a not straight line. Okay, let me draw here and tell you this is a straight line. If you draw it slightly like this, now it is not a straight line. So this is called linear. Okay, this is deviation. This is deviation. Okay, totally. Of course, the air resistance will not change the straight line to like this. Like this, it will not change. That kind of deviation is not there. There is a deviation. The deviation is so as to, this is there. Okay, the deviation is to slightly deviate from the original straight line. Okay, so let me erase this. If it is the case, so we will change this particular straight line and then make a slightly curved one and then draw it. So it could be like this. For example, you can slightly change the straight line behavior. Very small change, not a big change. And then this particular point is here as usual. And then here also, you don't put a straight line. Slightly deviated straight line you can put. Everything else is same. The point U is same. Point U. This is T1. And that would be T2. This is the time, and the y-axis is velocity. The origin is also there. So everything is same. The only change is that this one is deviated from. That is what you called a slightly deviated straight line is what we called a curve. We don't have a perfect straight line. Now we have a curve here. So that's all. That is what is the important point. If the air resistance is not neglected, remove this perfect straight line and put slightly modified curve. You should not draw too much turning. That is not the effect of air resistance, and therefore the curve will be looking like this. So our final answer is this. So which is the final answer means this is the final answer. Let me put a box. That's all. You have to see the question paper and find out whether this answer is given or not. Yeah, here is the full question where you have the 4 options are given. So 4 options are given to you, A, B, C, D. You can clearly see that which option is correct. So this is the correct answer that we have. This is the wrong answer. Let us see why it is a wrong answer. You can quickly tell this is the wrong answer because this portion is a straight line. That is why it is wrong. This is the wrong answer because this portion is a straight line. This is the wrong answer because both the sides are straight line, and that is not possible if you are not going to ignore. So therefore this is also not correct. You should have a little bit of curved nature on the track wherever there is a air resistance. So therefore the correct answer is D. Okay. So we will see more questions in the next lecture.